All right, let's dive straight into our very first chapter in the course, which is What the Hell Are AI Evals? This chapter should give you a lot more information on the terminology that we'll be using, and also it will set a foundation for the rest of the concepts that we teach in the course. You've probably taken this course and you're listening to me right now because you have heard the term evals that being brought up in the context of AI products and being brought up so many times, and everybody using it to mean very different things. There are all of these new companies that are saying that our experts are writing evals. Evals is the product moat, or product managers should be writing evals and all of this. And in your mind, maybe you associate this with things like LLM judges, or things like dashboards or A/B testing and all of this, right? And the goal of this course is to give you a mind map to understand what evals mean, what everybody means when they're saying evals, because sometimes they're just not aligned, and also to ignore the term itself and speak a bit about the process, which is the process of evaluation and building a good flywheel so that your AI products can improve over time, right? So we'll be taking more of a first principles approach. We won't be obsessing about the term itself, and we won't be referring to specific tools or having very prescriptive ways of explaining it, but just give you an overview of, if you have to build reliable AI products, what is the process that you should be putting together. This kind of goes back to why AI products are different than traditional software and why this entire area of evaluation has become so much more important. If you think of traditional software, think of something like booking.com or any other common website or a desktop application that you use. Most of the times, the user actions are very limited and predictable, which means that if I have to make a booking for a hotel on a particular date, I'm generally trying to click on a bunch of buttons. I'm going through drop downs and things like that. So user actions are very limited. And then the output is also very well defined, right? If I click on something, the absolute next action would be for a web page to open up or for a transaction to complete and stuff like that. So generally, there is a user input, there is a very predictable outcome, and the process that leads to it is also code, which is very deterministic in nature. And in order to test this entire process, test this entire workflow and say whether it works end to end, teams generally rely on unit tests, integration tests, and all of that. And they work well as well, because the core assumption here is if you have tested an input X, an action X, and the system reliably produces an output Y or an action Y, it can do that every time a new user comes up, etc. Right? So if you've tested something thoroughly before shipping these input actions and output actions of a particular application, the kind of issues that you will see in production are very related to what you will see before production as well. So you can simulate that behavior beforehand. But with AI products, this kind of a core philosophy changes a bit more, because the kind of user experience in AI products is that there is a natural language input, or there is some free form input, and there is this AI model, which is the core of your AI product, which is making a decision on what the output actions should be, etc. Right? So there is a much larger surface area of how users could interact with the system. They could say a bunch of different things, and it's impossible to predict upfront how they interact with the system. And the process, which is the AI model that's generating the outcomes or the actions, is also non-deterministic in nature. It's probabilistic in nature. And so you could come up with multiple different output types, right? So in traditional software, the input, the process, and the output are relatively deterministic in nature. In AI products, the input, the process, which is the AI model, which is generating the output, and the output is also pretty non-deterministic because it's all guided by a probabilistic model, right? And that's why testing these systems becomes a little different than traditional software. So this is essentially a summary of what we discussed, which is AI breaks classical assumptions by having an unbounded input space. It's often ambiguous, it can be incomplete or unexpected, and you as a builder can no longer control how the user frames requests. Obviously, there is a ton of amazing things that you can do with the user experience itself to constrain what the user is communicating, but really think of it, it's much larger surface area than traditional software, right? There could be text, there could be voice, images, video, and all of these amazing things. And then there's a non-guaranteed output as well, because models are highly sensitive to context, they're probabilistic in nature, small phrasing differences can change the output and things like that. That's the crux of why evaluation as an idea has picked up so much momentum in the past few years. So, how do teams actually build with confidence given that we don't know how users might interact with the system and how the model, which is the crux of the AI system, behaves? Is to think of this framework, which is user behavior or user input, expected behavior or expected output, and the system behavior or system response, right? So have this kind of an expectation table where you put together, oh, what kind of queries might my user come up with, and how should the expected response or action look like that for that, and currently how is my system behaving, right? These three items are super important in order for you to get started on the evaluation process. Seems simple, but we'll discuss a bit more on how this can get complicated as AI systems get more complicated. And again, I want to come back to this idea of the word evals causes a lot of confusion because it seems to be referring to multiple different things, right? Like benchmarks, LLM judges, A B testing, production dashboards, and all of that. And in this course, we'll cover all of those concepts, but as part of a process, not as independent terms, so that you can understand what the process of evaluation entails and not really get confused when someone throws the word around just like that, right? There's also this concept that we will talk a little more deeply about in the next chapter, but essentially, people tend to use the term evals for two different things, which adds to the confusion, which is model evals and product evals. Remember that in AI products, you have the model, which is almost like the brain of your product. And then you have a bunch of other things which makes the model work in your ecosystem, right? This could be tools that the model is calling or knowledge bases that the model is calling. And when I say tools, it could be just pieces of code or functions that the model is calling. For instance, if you're building a customer support agent, the model is the brain of that agent, but then it might be calling a bunch of databases in order to get customer information, in order to answer their questions. It might also be looking up historical conversations and things like that, right? So in your ecosystem, the model kind of interacts with other tools and knowledge bases. So whenever someone says model evals, it generally refers to evaluations that frontier labs or independent researchers have conducted on data sets, right? So if you've heard of benchmarks or data sets like MMLU, or if you've heard of independent benchmarks like LM Arena, these generally are telling you how well a model is performing for a given set of use cases that they have devised on their own. And they test things like reasoning, recall, coding, and all of these things, right? Which is super useful because it tells you how good these model companies are. For instance, when you are a product builder, you want to choose the right model for your system. You can look at these benchmarks to say, okay, OpenAI models maybe always perform well for writing content, or Claude models perform really well for coding tasks and things like that. That gives you an idea, a general idea of where models are. So these are model evals or model benchmarks. We'll go a little deeper into what that means. And then there are product evaluations or product evals, which is what we should be caring about as practitioners, right? This is basically how well does your product perform for a given use case under the given constraints, which are basically your tools, your knowledge bases, and all of those things, right? And we'll go much deeper into this, but just understand that evals can have product dimension to it and model dimension to it. As practitioners, you want to be caring much more about product evals than model evals. All right, this is some key terminology that you should keep in mind when we discuss concepts throughout this course. We've covered some of it, but we'll be going deeper into some of it in the next few chapters, right? Evaluation is basically the overall process of assessing how an AI system behaves. And it's not a single test, it's not a score, it's not a dashboard, it's the process. And that is the process that we'll be learning about in this course. A metric is basically a dimension that you measure on, right? Some examples could be correctness, helpfulness, tone of your AI system, and so on, right? And each metric basically answers the question of what aspect of quality or performance are we judging. Generally, people use the term evals to refer to metrics or to refer to the process or whatever. So that's why we're creating that distinction and telling you that evaluation is the process, metric is the dimension that you're measuring against. And rubric is the criteria that defines good or bad, right? For instance, if you have a metric called helpfulness, you need to have rubrics around what does a score of very good look like for a particular metric. So helpfulness as a metric is useless if you do not have criteria or a list of checkpoints to define what good or bad looks like, right? So those are rubrics. And a benchmark is basically a data set of these metrics and rubrics with those metrics. This is a really nice example to show you what a metric, rubric, and benchmark is. Metrics are things like correctness, helpfulness, safety, etc. Rubric is what defines those metrics or the criteria that define those metrics. For instance, helpfulness for a customer support agent could be something like directly addresses the customer specific question, provides clear, actionable next steps, and those kind of things, right? And benchmark is essentially a few test cases for each of these to say what the expected behavior would look like, right? Maybe you have 3 different metrics and you have rubrics that explain each of these metrics, and you have 50 test cases for these. So that's your benchmark, or it is also called as a data set in traditional machine learning. So the key takeaways from chapter 1 are this, which is the term evals is quite overloaded. People mean very different things. So we'll try to reduce the usage of the term and give you more an overview of the process itself in order to make sure that your AI products are good, they perform well, and they also improve over time. And the second takeaway is AI products are non-deterministic in nature, which is why the whole discipline of evaluation makes a lot of sense. And then the third takeaway is don't be obsessed with which model is performing the best on a particular leaderboard or on a particular public benchmark. That is useful for you to narrow down or think about where the AI model space is headed or which frontier lab is the best at this point and those kind of things. But it's not super useful when you build your products, right? Especially because so many players are getting to a point of parity that it doesn't make sense for builders to obsess over model evals. So now you understand why AI evaluation is unavoidable. In the next chapter, we'll talk a bit about how this evaluation is actually done, and we'll also go a little more deeper on model evals and product evals so that it actually drives home the point that model evals are not super helpful for product builders.